Okay, we're good. Hello, everyone. It's Peter from the DevRel team at R3. Today, I will host a very quick webinar. It's the Token SDK sample code walkthrough. So it's gonna be like 30 minutes to 40 minutes. It depends on like how quickly I can get through the all the code. And in the chat, we have David Watt, also a developer relations developer evangelist working at R3. He will be in the chat to answer any questions. So feel free to say hello in the chat, or if you have specific questions you want to like send it to me or David, you can send a private questions via Q&A feature of the WebEx. So let's get to it. So last week we had webinars, and the host was actually our favorite host, David. He was doing a token SDK walkthrough. So I'm gonna begin from there. So the token SDK provides a standard library to create and manage tokens in Corda. Oh, I see someone has a chat that there's no audio. I just want to check with David. Is there audio coming in, David? Can you hear me?
Things sound good. You
Okay.
may need to hit the connect to audio button, Albert. WebEx might need that from a couple people, depending on how you joined.
Oh, right. So originally we were in practice session. So when I switch to the real sessions, I think you need to reconnect audio. Let me get to it. So again, the token SDK provides a standard library to create and manage tokens on the Corda systems. And if you don't know what's a Corda systems, you can feel free to go to the YouTube channel. Just go to YouTube and then search for Corda. You can go onto our channels and then you can find any recordings of our Corda 101 or the Corda developer bootcamps to have to learn about what's a Corda system. But today's webinar is kind of focusing on how to actually implement using a token SDK library. So inside of the token SDK, there are 4 primary features or functionalities of managing and basically developing tokens are the create, issue, move around, and lastly redeem. So the create is very easy. It's like you can use the pre-built functionalities in the token SDK library to create the underlying token type for the token, whether it's fixed or evolvable. We also covered that in our previous webinars. The second is issue the tokens to designated holders. So you can issue it to yourself because in a lot of scenarios, that's what the issuer will do. For example, when let's say the U.S. Federal Reserve want to print some money, or want to issue some U.S. dollars, they don't just print the paper and then deliver to you. They will print the bill and then issue it to the Federal Reserve, and that will get delivered to you afterwards. So that's actually is the third features or functionalities of the token SDK, which is to move the token around the network. Just similarly as you got the bill that delivered to your bank, and then your bank, you can get the actual US dollar from the ATM machine. And lastly is a redeem. So the word redeem in US in the normal English context means you exchange your token for something. However, that's not how the word is how the functionality is used in the token SDK. So in the Corda world, in the Corda token SDK world, the functionality called redeem means that you want to sort of consume the token. That means you no longer want your underlying asset to be traded on the open market. That means, for example, you buy a very precious painting from someone from like say auction market, and then you receive the actual painting and you hang it up in your living room. At the same time, you receive a digital token on the auction Corda network to represent that you are the holder of that painting. So one day if you want to sell it, you just like you put the tokens on the network, and other buyers, they can see the token, they can verify it, and then see the whole history of the painting from that token. However, if you say, okay, I love it so much, I don't want, like, I'm not planning to sell it anyhow in the next, forever, eternity. I want this painting for the rest of eternity. So what you can do is you can redeem the token, meaning that you take the token, go to the auction party saying that I want to move the actual painting off the auction market. And I'm not planning to reopen any, I'm not planning to put the painting back to the market ever. So it actually doesn't matter that I destroy the history just right there. I mean, the proof of transaction, the history of transaction, everything. I don't care because I will be the last owner of this painting. So in that sense, that's the word redeem meaning actually destroy the token, or we can call it consume the token, and claim the asset itself and move the asset off the ledger from there. So yeah, so basically that's a quick recap of the 4 functionalities, and now we will be jumping into the code. So today I'm going to go through the code walkthrough with a CorDapp that I developed a couple of months ago. It's called the Back Market. So it has both Java version and Kotlin version. You can get a copy of the code if you just go to github.com/Corda. You're gonna see. Actually, I can quickly show you. GitHub/Corda/samples Java. If you are a like Kotlin developer, you just like change the Java to Kotlin. So you go to the token samples. We have more samples in there, but for today's walkthrough, we're gonna take the first one, which is the back market. So this sample depict a simple bicycle trading market. So in this network, we have a couple of participants. We have the bike company, we have a licensed dealership. That's basically is a subsidiaries of the bike company. We have a used part agency that's kind of break the bicycle apart, the wheels token and the frame token, and buyer. So from the arrows, you can see the buyers can buy the bicycle directly from the company, or buy from a local licensed dealership, or just buy the parts from the used part agency. So a little bit unconventional, or I wouldn't say unconventional, it's a little bit or more realistic aspect of this CorDapp is you can actually buy bicycle with parts, meaning that a bicycle has 2 parts. And if we sort of create a token representing the bicycles, we will be transferring 2 tokens at the same time. And then when you have 2 tokens at the same time, it means you have a whole bicycle. Actually, that's very realistic. I'm not like making it up, because I have a colleague that, oh, my video is off again. That's really weird. Let me turn it back on. So like buying parts with bicycle is very realistic, because with like luxury and bicycles or high-end bicycles, the parts you will need to buy parts separately. Like they just don't sell whole bikes. So with that said, in my CorDapp, the CorDapp, the samples that I show you today, a bike has 2 parts: the frame and wheels tokens. So that's just like one thing that you wouldn't like normally like experience, but it's an actual use case. So let's see. So what we gotta do here. So when you thinking about implementing a CorDapp token enabled CorDapp applications, the first thing you need to do is, again, implement the state. So today I'm showing Java because we want to be like, Java friendly. And if you are Kotlin developers, it's just like, you're gonna have less code. That's just the benefit of Kotlin. But today we are sticking with Java. So if you have been to our Corda webinars or developer bootcamps before, you know that we said that every Corda state extends a Corda contract state. However, that's not the case here, right, today, because you don't see, oh, where's the Corda contract state? So if you look, if you click the evolve token type, you're gonna see that evolve token type is actually a linear state. And the linear state, if you click that, again, it's okay, so it's a contract state. So that means the evolvable token type class is actually is an interface that's already implements the contract state. So what we need to do is just extend the evolvable token type, so we can just enjoy the automatically fill up method there for us. So we don't need to like worry about, oh, do we need like a fraction digit? Do we need like maintainers? Those are override method gonna automatically generated. So that's actually another trick when you're developing a CorDapp in IntelliJ. You just comment in, it's gonna generate all the constructor, getters, and overrides for you. So let's take a look at code. So when we create a wheels token state, which is an underlying token type, what are the things that we have to implement? So let's begin from the overrides, because those overrides are the must-have, right? So first, it says, oh, I want a fraction digit. So what's a fraction digit? So fraction digit means how many decimals you want your token can break up to. So that means, for example, US dollars or any currencies in the world can break up to actually 2 digits, the cent and then the penny, right? So that's like a 2. And Bitcoin can break up to 8 digits. So that's just how it is. And so in our token SDK samples, we give you the sort of flexibility for you to choose how many tokens you want to break your how many digits you want to break up your token to. And for today, we are using tokens to represent bicycle parts, right? Frame token, the frame and then the wheels. So those are non-fungible, meaning there's no way I can split up a frame into half and then expecting it still works. So in my case, you will see later that when I actually create the frame token or the wheel token, the fraction digit, I just put it 0 as default. And the second one is get maintainers. So this is an interesting attribute, because when you create a token, so especially when we are creating an evolvable token type, meaning that we are expecting one day we will update some informations of these tokens. It need to have a maintainer. Maintainer meaning that they have the permission to update the token. So in this list, it's basically just say who has the permission to update the tokens. And lastly, it's just a linear ID. So that's like used to identify like what it is, like which state exactly it is. And then it's our custom attribute. So in this case, for simplicity, we only have like 2 attributes. One is the model number. So when you create a token, when you factory make a frame, the frame will have a model number, or you can call it a serial number. And yeah, that's it. So the get issuer, I was just writing a helper method, just return a single maintainer, because in this case there will only be one maintainer of the case. So this is just like a helper method that sort of give me a single maintainer. So yeah, there you have it. That's wheel state. So after we talk about state, we're gonna talk about contract, because state always come with a contract. It's just how it is in the Corda world. So let's go to the wheels contract. Very empty. Why is that? So normally when we tell people to implement a contract, we always say, okay, never leave your contract empty, because like at least have something, or like make sure you thoroughly design your application so your contract is not empty, something like that. But why are we having sort of like a simple like empty contract? So that's actually not the case, because if you look a little bit closer, we are not just implementing the contract, because if you have been on our previous sessions, every contract actually has a method called verify. In that verify method, it's gonna check a lot of things, like, for example, do you have the correct input? Do you have a correct output? Stuff like that. But you don't have it here. But you can still run this app. You can still run this app. Like, why is that? So the reason is we extended a mid layer called the evolvable token contract. And if we go in that, so we actually see all those pre-written contract code that is already there for us. So when I extend my will token contract out of the evolvable token contract, all these verified contracts will automatically run. So if you take a look at my code, it actually says additional create checks or additional update checks. So these additional create checks and additional update checks are when I'm not satisfied with the default contracts, which are already checking a lot of the crucial things, like what's the command, is the input empty, stuff like that. When I want to have any additional checks, I implement here. And also, as a result, for the simplicity of the samples, we did not implement any additional create and checks or any additional update and checks. So that's it. So like we are not being lazy to not implement it. It's just like for the token SDK software developer kit, it already come with quite a lot contract verifications if you implement the evolvable token contract. So far so good, right? It's pretty easy to just implement the token state and token contract if you just implement the evolvable token state and evolvable token contract. Cool. What does the evolvable token? Okay, so I think the question is like, what does the evolvable contract verify? I guess maybe that's your question. So the evolvable contract verifies a couple steps. One is create. So just as any other like sort of like token creation verifications, it requires a couple things. So it checks if the input is empty, because you are creating something out of nowhere. So that means you are not taking any input. I mean, I don't know if you can like get that sort of, it's a Corda concept, because Corda use UTXO model, meaning that if you take something as an input, you are consuming that thing. But in our case, when you create a token, you should not consume anything to create this. So one thing that it verifies is like the input must be empty. The second thing it checks is check the output. So it requires the output size equal 1. That makes sense, because you want to create one token type at a time. You don't want to create another token type with the same serial number, so you can start double spending. So you see, all those checks are implemented by us, that we make sure that your app just function normally and don't have like a mischievous stuff. And another thing that it checks is like does the signer is like is a sort of like the maintainer or the creator of the tokens, are all the maintainers, are all the participant of the state. That's like to check that, are you forgetting including someone in this token creation process, stuff like that. Yeah, and that's like asking like, are they all signing the same transaction? So those are the normal things that most sort of a creation procedure would check. even if you implement your own CorDapp. And with the token SDK, we already implemented for you, so you can just use it. Yeah, I hope that answers your question. So I'm gonna continue. So we also have like a verify update. Yeah. Sure. Let me get to the actual code for you to create the token. So we were talking about the wheels token. So let me actually also just talk about create wheels token. So here's all the magic begins, right? So you have your wheels token state, also your frame token state, and you have your contract. Now let's create some tokens. So the token creation is very simple in if you're using the token SDK. So you see, like it only needs like 1, 2, 3, 4, 5 line of code. Yeah. So what we are doing here is first we need to get a notary. So token state is just as another contract state in the Corda system. When you do a transaction, you need to have a notary to basically record your transaction, record your action. That's the first thing. And second thing is we are creating a UUID. So that's the unique identifier because we want to do queries based on the UUID. So we know what we just created. And then here, that's the wheel token state that we were talking about. It has a couple attributes, right? Like we see it here. We are creating the token state right now. So new wheel token state, the first one, let me actually bring this up. Command P. So it's going to tell you what are the parameters. So the first parameter is the maintainer. In our case, who's the creator, right? Who also holds responsibility to update the token later in the future if like we need it. The first is a maintainer is us. So we put in get our identity. The second is a unique identifier for us to uniquely identify the token we created. We use the UUID that we just created. And here is a fraction bit that I was talking about, that how many decimal points that we will be able to break your token to. And in this case, it's 0 because we don't want to break our token into any pieces. We are issuing a non-fungible token. That means do not break it apart. And lastly, is the only sort of meaningful attribute related to this use case is a wheel model number, or you can call it serial number. So there we have it. That's our state. And what we need to do is we need to wrap it around our wheel token state into a transaction state, because we want to tell notary is, okay, here's I'm gonna do it, and I want you to notarize it. And we basically attach the notary into and the frame token. Oh, I call it the frame token. Okay, that's a typo actually. My bad. So I think I was copy pasted wrong. I'm gonna quickly update the GitHub when I get a chance. So wrap around the wheel tokens and the notary, and then into a transaction state, and then just dump it into a method called create evolvable tokens. So what does create evolvable tokens means? It's just gonna trigger a pre-built token SDK method and just create the token for you. It's gonna go through the verify method, verify create, and then etc. It's gonna give you the state. So you see, if you run the app yourself, you're gonna see that create a wheel token for back wheels, and the serial number is the wheel model. I see another question is, what's the benefit of breaking up the tokens to fraction digits? So let me take a sip of one. So in today's samples, we are talking about non-fungible tokens, meaning that one token represents one item. Like for example, if I issue a token for my phone, that's one token. I couldn't break up the tokens and I only give you like half of the phone. You wouldn't take it because that's useless. However, we do have a fungible token, meaning that, for example, if I have a, I have a, let's say, okay, I just gonna use some like medicine, cold medicine as an example. So in this like palette of medicine, it has right now it still has like 8 pills left. That's just a medicine, right? So I can issue 8 tokens representing no, I mean I can issue 8 same tokens representing each pill of the medicine. So that's what we call sort of something like fungible token, meaning that the definition of the token is the same. It's just a pill of medicine, and the quality or like the characteristic of the medicine is the same. So that means the token is the same. However, I can break it apart and then like put it together. For example, if I want to give you 2 medicine, I give you 2 tokens. And if I want to give you 5 medicine, I give you 5 I give you like 5 tokens. However, I can also break it into pieces, meaning that I give you 2.5 tokens, meaning that I'm gonna give you 2 pills and like one I smash it half for you. Maybe it's like a child dose or something, like a dose for like little children, like something like that. So it really depends on your use case. Like the purpose of fraction bit is you can break one thing into break the actual asset into different pieces. With the frame and the wheels, you cannot break into pieces. But with like for example medicine or one of the easiest understandable example is the U.S. dollars. You have $100 bill, you have $50 bill, you have $20 bill, you have $1 bill. However, you can also go into decimals. You have a quarter, you have dime, you have pennies. So those fraction bits are just for smaller quantity of the actual asset. So that's why like we offer fraction digit. Yeah. If you only thinking like your asset and the token is one to one, then just don't worry about it. Put a 0. Then that means you are issuing a non-fungible token. So that's a little bit about why we care about fraction digit. Okay, back to the CorDapp. So we just went through like how to create a token state, and let's now issue this token, issue this new bicycle. So we go to the issue new bicycle. We see a bit longer code here, but bear with me. It's just a repetition of a chunk of code twice because a bicycle has both frame and wheels. So let me get to it. So the constructor for the issue new bike has three parameters. One is a frame serial, and then the wheel serial number, and the party, which is the holder, representing like who are we issuing the token to. So going into the call method, first thing first, let's take care of the frame token. So the frame token, we're gonna do a query first. So this chunk of code is we are just using the serial number to go to the database and then return this frame token state. And we extracted and actually get the frame token state. This code is we don't need it anymore because we have this nicely written Java utilities from one of our coworkers. Like originally, the code that's issue a token will be like 10 lines more, but he said like enough of this. He wants like less code, just like Kotlin. So he create these Java utilities. So we're gonna use these Java utilities to actually build the token, a non-fungible token. So you can see that it's called a non-fungible token builder, and we have a like method called of token type. The token type is a frame token type dot to pointer. So you may wonder like, oh, what's the to pointer method? So this to pointer method is what we wrote in our token state and frame state. So it's just like a helper method. It's up to you, like if you want to use the way it is, or you just like you can just take this part and then copy paste into your issue code. But we like it have this helper method here. So basically, it's just take the state and then make it to a linear pointer, easier for the token SDK to understand like what exactly is the token type. So that's that. And we have a method called issue by, which is us, get our identity. And then help by is the parameter that we pass in, which is the holder. And lastly, we have this, very awesome Java utilities that build non-fungible token. It's actually gonna build the token. So what we are getting out of this like pretty long method is a non-fungible token. That's right there. But not issuance yet. We haven't done any issuance yet. We just like create the token first. And second step is we're gonna take care of the wheels. Exactly the same thing. We use the wheels model and we basically go to the database and retrieve this wheel token state. And we extract that from the return from the database. And yeah, don't worry about this line. We're gonna use the Java utility because it's just the nice feature. Same thing again, non-fungible token builder of type, which is the wheels token type 2-pointer, issued by us again, held by holders, which is again, we pass in the parameters. And then we call build non-fungible tokens. So that's the second step. So the third step is we're gonna actually call the issue tokens. So the issue tokens is again a pre-built method that's from the token SDK that we just pass in the frame token and the wheel token, like whatever token that we created before, and pass into this method, and the token SDK will take care of it. Will deliver the token from what you just created to the holder that you basically choose to hold the token. And that's basically it. That's the issue. That's the issuance. So far we already talked about create and issue, and now we're gonna go to the move. For the move, I'm gonna go to. So if you can see, there are two methods. One is called transfer bike tokens, and one is called transfer part token. Because again, I talked about it in like before in our in the diagrams. You can buy the bicycle as a whole, or you can actually buy parts. So let's talk about transfer bike token, because meaning that the both token gonna get transferred at the same time. So click that. So talk about parameters first. We have serial number and wheel number, frame serial number and the wheel serial number, and then the holder. Because we are doing a transfer, meaning that get from one identity, like one identity on the Corda network to another identity on the Corda network. So into the call method where all the the action actually happens. The first thing first is we're gonna do a query again, because we have the frame number and we want to get the frame state. And we extract the state into the actual from the queries, and we get the frame token pointer. So it's similar what we do with the helper method that we wrote, almost identical. But now we are just like using a different way, because our utilities will take the token pointer, which is a different attribute in the token SDK. So I mean, if you ask me like why I am like, there's not a specific reason behind it, like why we are taking the token pointer. It's just how it is. Like if you want to move the token around, you gotta give the token pointer. So the move method will know which token you want to move. So we just take care of the frame token pointer, and now we're gonna take care of the wheel token pointer. So we're gonna again do the query again, use the wheel model, and then the wheel get the wheel token state from the as a query return, and then extract the state from the query, and then we're gonna get a pointer from that specific token state. And here is something that's the Java utility that our coworker Anthony developed. So we're gonna build a transaction like how you build like a Corda transaction from without using token SDK. If you familiar with how you do that, is you do a new transaction builder, you pass in the node tree, and here are the methods that from the Java utility is we want to add the frame token pointer and the holder and who we are into this transaction builder. And we're gonna do the same thing for the wheels token. So basically this step reduce a lot of like hassle that we need to manually add the receiver add ourselves and add like the payload that we want to send attaching the transaction. All in one into one method called add move non-fungible tokens. So that's pretty awesome about these Java utilities. And then the rest of the flow is just how you do a normal standard Corda flow is you sign it yourself, and then you send it to counterparty to collect signatures. And then lastly, so these are the two methods that it's a little bit advanced, but it's a little bit advanced, and we are actually not even using that advanced features in this simple CorDapp. Is broadcast the updates of the token to any observers because we don't have any observers. But if you do, just call this method. So in our case, even though we don't have any observers, we just want simply to finalize the transaction, but it's still good practice to just use this very awesome method called observer aware finality flow. Because it can automatically identify, do you have observers? If you do, it's gonna update the observers. If you don't, just like pass it and then pass it directly to finality flow. So it's good practice to just run these two flow. And also this one is update distribution list. So this flow is when you have a token updated by the creator and there are many holders of the actual tokens. So this method will actually automatically update, basically tell the holders of the current token that, oh, your token issuer or the creator of issue had made some small modification of your tokens. Take a look, something like that. Yeah, so it's good practice to always use these functions. And so that's a return message, just a simple string. So for the responder, you don't need to do anything. You just need to like basically call the move non-fungible token handler. Yeah, so that's how you move a token around. And that covers the third topic of our webinar today. I see a question, is there a recording I can view later? Yes, the recording will send to your emails where you sign up at first. Yeah. And lastly, let's talk about redeem. So remember, like before I actually jump into the code, I actually spend like 2-3 minutes explaining like what does redeem mean. Redeem meaning that move the actual asset off the ledger and basically call it off on the tokens. So the token is consumed that you can no longer transfer or you can no longer like consume the tokens, and the asset is move off the market. So nobody can really like see it except yourself. yeah, because the token is consumed from your database and the creator database. So yeah. So let's get to it. So in these samples, I have a method called total parts. And if you look at the diagram, so basically is where the buyers have a damage in the parts or like want to replace the part. So the buyer need to total the bicycle, or like a total one part of the bicycle. Either the buyer gonna total the wheels or the buyer's gonna total the frame. Total meaning like destroy it or let's say send it back to the bike company, and the bike company can issue a replacement or something like that. I'm not like really covering that part, but the action that depict in the total part is the buyer in real life gonna send back the actual asset, but in this CorDapp, the total parts method gonna basically send a request to the back company, which is the creator of the tokens, and the token will be consumed, also like sort of like destroyed. So let's take a look at how it's done. So the total part has two parameters. One is like what's the part you want to total, whether and here's a simple if else. If it's a frame, then the serial number is a frame serial number. If it's not frame, then its default is the wheel number, wheel serial number. So yeah, that's basically it. Collecting some information in the constructor. And here's in the call method is also a big if else like condition check. If it's a frame, if the buyer want to total the frame token or actually the frame part of the bicycle. First thing first is queried from the database. Second is extracted from the return queries. And here's is the helper method that I mentioned in when I go through the state is I just want a single maintainer. I don't want the list of maintainers. So I create a helper method, just get me the issuer, right? And now I have the issuer. I get the token pointer because I want to pass into a method called redeem non-fundable tokens. It's taking a frame token pointer, and it asks me, okay, who's issuer? I give that two pieces of information that it needs, and that's it. I don't need to do anything afterwards. For the second part, it's just a else condition of the if else doing the redeem for the wheels, and for the responder. I just so this responder will get invoked from the issuer part, which is the bike company. It simply just need to take redeem non-fundable token handler, and it takes the counter session. So yeah, the redeem logic when you actually implement on code is very straightforward. It's just like the thinking or the logic, the business logic of what do you mean by redeem a token. It's a little bit tricky. I'm one of my colleague who's a solution engineer always like to use analogy, or what I say a different analogy to explaining the redeem Corda Token SDK redeem functionality is, for example, you buy a can of fish from the market. And when you purchase it, the market will give you a token representing the can of fish or sardine or so ever. And when you go home, it's lunchtime. You opened up the can of fish, and then you enjoy the fish with your families, and then you leave with like a like the can empty because you ate the fish. So that process is actually a redeem in the Corda world because you consume the actual asset, so your token doesn't represent any value anymore, and you know that your token is useless now. So you go to the market saying that I ate my fish, here's the token. I no longer need it, you can destroy it. So that's another analogy to explaining what's like redeeming the Corda world. Yeah, that's it. It has been like 45 minutes. I hope everybody have a quick overview of the token SDK package. And that's it for today. I hope to see you all in our next session. I think our next session is on the Corda certification prep course. So we also have a recording. Yeah, hopefully to see you there. Thank you, everyone. Thanks.